In this video, we are going to graph a polynomial function. So first, a couple reminders. A zero factor solution and x-intercept, they all kind of talk about the same thing, but in a slightly different way. So a number k is a zero of the polynomial function f. A factor would be x minus k. That's a factor of the polynomial f of x. The solution k makes f of x equal 0, so f of k would be 0. And if k is a real number, so it's a rational or an irrational number, that's also going to be an x-intercept. So in this first graph, we are given a function that's already given to us in factored form, which is why I kind of make sure we know what a factor is. Step one, if you see this, is find your solutions. In factored form, it's super nice because I have x plus 2 equals 0, x minus 1 equals 0. Technically speaking, I have x minus 1 equals 0 twice because x minus 1 is being squared. So I'm going to make sure I note that x equals 1 is a double root. So on my graph, I have x being negative 2 and x being a positive 1. That's a double root. I need to now pick more values because obviously 2 is not enough. But even before that, I might notice what my highest powered term is. It's kind of hard to see in factored form things because it's not quite as obvious. But this is x to the first. This is x to the first squared, which means that there are 3 separate x's being multiplied together. This is an x cubed graph, so I should have 3 solutions, right? Which also is important because now I can know my end behavior. Compare that with my a value, which is positive. I know my end behavior should look something like that. As x goes to the left, we go down. As x goes to the right, we go up. Okay? So now I'm going to pick some values to the left and the right of each solution. What numbers you pick don't ultimately matter. There are good choices, there are bad choices, and you will know if you've made a bad choice after you've already gone through the process, because ideally we want to be able to graph these numbers. So I'm not going to pick x is negative 1,000. That's not going to fit on my graph. The closer we are to our zeros, left and right, the more likely it is to stay on our graph. So I'm going to pick x equals, let's go negative 3. I'll pick x equals 0. I'll pick x equals 2. Okay? Here's my rationale for each of these. In step 3, we can use synthetic or direct substitution to figure these things out. But if I use negative 3, for example, synthetic substitution is not a great choice for me right now because I don't know all my coefficients. I would have to multiply it out. I don't really want to do that. So I'm going to do f of negative 3 the direct substitution way. So negative 3 plus 2 times negative 3 minus 1. And I'm just going to write negative 3 minus 1 twice instead of squaring it. And this is why I think negative 3 is a good choice, because I'm going to end up with 1/4 times negative 1 times negative 4 times negative 4. This 1/4 gets rid of one of those negative 4s. So I'm left with negative 1 times negative 4, which is 4. So at x is negative 3, I go 1, 2, 3, 4. Right? As I continue on, plug in another value. X is 0. F of 0. Okay, I have to still multiply this stuff out, which is not as fun in this case because I'm going to get a fraction. 0 plus 2, 0 minus 1, 0 minus 1. Okay. 1/4 times 2 times negative 1 times negative 1. 1/4 times 2, which is 1/2. Negative 1 times negative 1, positive 1. We get out of the way. All right, so 0, 1/2. I'll zoom in to try to get that close. Okay. And then just for space sake, I'm going to do f of 2 up here. 1/4, 2 plus 2, 2 minus 1, 2 minus 1. 1/4 times 4 times 1 times 1. Again, 1/4 and the 4's cancel. This is just going to give me 1. All right, so I've got 5 dots. Wonderful. This is where I connect the dots with the smooth curve but I have to keep track of duplicated roots and end behavior. I know that I already have a mistake in my graph. Right now, I know it. Because I know, like we said right there, I should be going down and to the left and up and to the right. And right now, it kind of looks like we're going to go, oops, I thought I had a pen. Looks like I'm going to go up to the left and up to the right, which would be an even power. So something went wrong. Well, the something that went wrong comes back to right here. When I canceled this 4 with the 1/4, it should have left behind a -1, which makes this not a +4, but a -4. So this one should actually be at -3, -4. Now it's looking more like the odd degree that we're supposed to have. So when I go to graph this, I go past, and it's going to look something like that. Right there was my double root, so I'm not crossing through the x-axis again. I'm touching the x-axis and bouncing away. All right, that's what it means to keep track of your multiple roots, your duplicated roots. And then your end behavior is always, always, always double check. Does it match the correct left, right, up, and down? Okay. Have a great day, everybody.